You have to be able to do that. You don't for today's quiz. But do you have to be able to do it for the exam? No. You don't for the exam either. Only for my test. Now, you have to be able to use all the laws on the exam, but you don't have to be able to recall their name. All right, so if we label what we know, volume is 3.84 liters. It says at standard temperature, so 273 K, and I'm sure y'all probably did like I did and made them the ones. V2 and T2, and we're looking for the second temperature. And what was the V2? It's 38. All right. Now, what is wrong with our problem? Volumes aren't the same. So, does it matter which one we change it to? What'd y'all pick? Okay, that's what first period did too. Okay, so milliliters to liters. 1, King Henry died by drinking chocolate milk. And you're going to find when we do this today that a lot of us are going to have to change to liters regularly. So if you don't want to have to do this a lot, from the baseline to milli is 3 spaces or 3 zeros. So if you don't already know that a milliliter is 1,000, you might want to memorize that one because you are not going to want to do this a lot. Okay? So when we divide, we get 0.368 liters. Now, if you weren't a fan of liters and you went to milliliters, you would have 3,840 milliliters if you chose to go that route. Okay? Either one is fine. Your formula for Charles' law is what? V1 over equals, okay? So V1 is 3.84 over T1, which is 273, equals 0.638 liters over T2. I noticed I was double checking myself to make sure I picked the right number because I have liters. I needed to make sure I picked the liter number because it's real easy to make the conversion and then forget to do what when I plugged it in. Keep the converted number. A lot of people will go back and still pick up their number that was original to the question. So make sure you pick the one that you convert. Okay? Cross multiply. So 3.84 T2 equals 273 times 0.638. So to get T2 by itself, I'm going to do what? Divide by 3.84. Divide by 3.84. And T2 is going to equal what when I do that? 45? Okay. All right. A couple people asked first period, 1 decimal places, 2 decimal places. If you do put the decimal places, it's fine. When I wrote it down first period, I think I kept 1 decimal place. Somebody asked me if it was fine if they had 2. Yes. Should you have more than 2? No. Eliminate after 2. Okay, we don't need that many decimal places behind the number. Now, should I go to Celsius? You can. I just wouldn't. The question didn't ask for it, so I wouldn't do the work. Any issues with number 1? Okay, number 2. So, number 2 says, let's here so I don't have to go between 3 boards. All right, so number 2 said find the what? Find the partial pressure. So this time I'm not finding total pressure, I'm finding partial pressure. So they already gave me a total pressure in here, right? So does it say collected over water anywhere in the question? Nope, so I'm not using that special formula. I'm using T total equals T1 plus T2 plus T3. Plus dot, 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 dot. Did you find the chart, John? All right. Did you give one to the name by any chance? Okay. Did you get the sheet offline from the put online? Yeah. You did. All right. So, since we're looking for partial pressure, that means we got to have the total pressure. So, what is the total pressure they gave? The total pressure was 7.5. 7.56 atmosphere. And if I keep reading, it tells me I have neon exerts the pressure of 850 torr. So that has to be one of my partial. Plus, if I keep reading, I have 156.8 kPa. And then it asks me what's the partial pressure of xenon, I think. Blah, 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 blah. What's the partial pressure of xenon? So we can either write plus P3, or you can do like several people did first period, and you can write the partial pressure of Xe. If that makes you happy, doesn't matter. Or you could just write P. It does not matter to me which way you do it. Okay? The biggest problem we have is they don't what? Yeah, they're not converted, they don't match. So, which unit do you like? Okay? I will tell you that based on what we're going to do today, after we finish today, a lot of you are going to go to ATM. So, I'm going to do it in ATM, and if you did your answer to TOR, I'll change the TOR when we finish. Okay, so 7.56 ATM. I'll change it to kPa for you. Okay? So, 850 TOR. 850 divided 760 is 1.11 plus 156.8 divided 101.325 is 1.54 plus partial pressure of xenon. So 7.56 subtract 1.11 subtract 1.54. I have 4.81 atmospheres of xenon. Now, if you have it in TOR, you should have 3,655 TOR. You should have 487 kPa. Question? Yes, sir. You go 4 what? There's a difference in probably how you round here versus how I round here. 4.91 and 4.81 are probably close enough. I would not get upset, particularly if you showed work. Okay. You got what? Again, probably a difference in rounding. Show work. You probably dropped off some decimal points that I kept. It's very possible. It's probably very possible because I didn't actually look at what I have down there. I also just kept what I had on the calculator and multiplied. Yes. For example, I have multiple people in second period who lost 2 points for using a calculator because they showed all their steps. And I have a few people who lost 10 points because they showed a lot less work, and I don't infer very well. I don't assume that you knew how you got from this step to the final answer if you don't show me the steps. But if you show me all the steps, and it's just like this, here, am I going to assume that you knew how to add and subtract? No. But if you showed me these two numbers added together and then subtracted, yes, I would assume you knew what you were doing. Okay? Particularly like here, if I go back to, what's the wrong direction? For example, if you show me all the way to this here, and you get the wrong answer, that's a -2 there because I know that you multiplied those and divided by that to get that. So I'm only going to take off 2 because you've shown me all of your steps. But if you don't, let's just say you leave me here and you don't show me any of this, do I have any idea how you're getting the answer? If you write T equals, let's just say you had 152 Kelvin, which is the wrong answer. All right. Do I have any idea how you get from here to here? I'm not going to try to figure it out either. I'm not going to try to guess how you got there. It's -10. And I'm going to the next question. Okay? Half the time I'm going to write -10 algebra and go on because I don't know what you did. It might be a calculator mistake. It could be an algebra mistake. I have no idea what you did wrong because you didn't show me anything. But if you've gone to the trouble to show me that you had P2 equals 273 times 0.638 divided by 3.84, which is the right math, but the answer is wrong, you know your algebra, you just had a calculator glitch. Okay? That's different than working it wrong. You get your blue sheet. Everything's on there. Yeah. PA. Exactly. Now, since we've done the opening questions, are there questions on anything that was on the homework out of those 8 that you tried maybe yesterday or you went home and looked at last night and you were like, dang, I don't know how to do that one, or I got the wrong answer, or maybe Ms. Wall needs to explain something further on that question? 16? Sure. All right, 16. Okay, so 16 uses the table. All right, so when we read 16, it said helium gas is collected over water at 25. All right, so since it says it's collected over water, that's P total equals P gas plus P water. So where did we say we always get P water from? The table. So look at your question. What's the temperature for the water in that question? So 25, right? So you go to the chart, and you got to find 25. There's 25 degrees Celsius on this chart. And did I use KPA or MMHG in the question? MMHG, okay? So 25 degrees Celsius, and MMHG gives us what number? All right, so 23.8 is our partial pressure of water. Now, we are either given in the question total pressure or the partial pressure. The question 16 says, what is the partial pressure? So are we looking for PT or P gas? P gas. Right? So that means P total has to be given. So what do we have for P total? 750. All right. So from there, what do? Find P gas. Subtract 3.8 on this side. Subtract 3.8 on this side. And P gas is what we subtract. 726.2. All right. Now, all right. So when I do that, what unit do I put on my answer? Well, what was the unit on the P gas? Or sorry, the P total. MMHG. So that's the unit that I put on my, millimeters of mercury. Anybody? Anything else is bothering you before we do the quiz? What? I had to work on in first period too. All right, so number 12. All right, number 12's issue is everything has to be converted. Nothing matches in 12. All right, so in 12, you have 2.71 liters. What's a liter? Okay, so that's V1. And then you have negative 18 degrees Celsius. What's a negative 18 degrees Celsius? Okay? And then you have 102 kPa. What's a kPa? That's the pressure. Okay, so I just made all of those the ones since they're the first ones listed in the question. They're all at and, so they're all together. So it says, at what temperature? So I'm solving for T2. And it has 3910 ml. So what's a 3910 milliliters? The milliliters. That's volume 2. So that means this 1274 has to be a what? Has to be a pressure. All right, because you're not getting enough sleep at night. All right, and I'm bored and central. So our problem is absolutely none of the units are in the right unit. The volumes don't match, the pressures don't match, and the temperature is in the wrong unit. So everything has to be converted. So the Celsius is the easiest one to do because it has to be changed to what? So negative 18 plus 273 is 255 Kelvin. So that one's done. Now, do we want liters or milliliters for our volume? What liters? All right, so milliliters on the bottom, liters on the top, 1 liter. This is why I said I'd memorize it to 1,000, because we're going to do this a lot today. Or y'all are tonight and tomorrow anyways. 3910 divide 1,000, 3.91 liters. All right, so the volumes are good, the temperatures are good. Pressures, you can make them both kPa, you can make them both torrs, you can make them both something else. What'd you pick, Isabel, since you're the one who asked for this? kPa. So I'm going to leave this one alone, and I'm going to change this one to torr and kPa. So 760, 101.325. All right, so 1270 times 101.325 divided 760, 169. Did you get that? I thought you studied really fast. All right, so V1, P1 equals V2, P2 over T2. Why do I feel cold air blowing on me? Got the air conditioning on? All right, so V1 is 2.71. P1 is 102. P1 is 255. Equals V2, 3.91. And P2 is 169. And T2 is we're looking for. Alright, so now I do what? Cross multiply. So I get 2.71, 102, and T2 equals up there 265, 3.91, and 169. Divided by 2.71, 102. Divide here by 2.71 and 106. Now, you see how I always draw in those parentheses when I'm doing that? You have to put that stuff in the calculator. No. Okay? So 255 times 3.91 times 169 divided by 2.71 divided by 102. 609 is what I got. What's the answer? That's what I got. Found your mistake, Isabel? Okay. What other things are bothering you? Anybody? Yeah. That's right. It's the one that's spread across. There's no denominator. So P times V equals P times V. Yeah. Yeah. The two that Andy has in his name is and yes. So, ready? Fabulous. You need your table, a calculator, and a writing utensil. I would recommend a pencil so that if you need to erase, you're not scratching out all over the place. You don't need a piece of paper. Even my fools who have the biggest handwriting in the world first period managed to get it on Swift paper. So y'all can do it. Now, you got at most 30 minutes. Oh, wait. Anybody else feel like the air conditioning is on? I mean, that's me. Yeah, but normally it doesn't feel like your air conditioning is on. You're still working. Yeah. You're crazy, you know it. Let's just sort them out. Okay. All right. Tell me when you don't have to start. Okay. Chin. Let's all start. All right. Give me a sheet. All right. Oh, we're done. Let's go to bagel. All right. If you will, find your cookie. All right, we're going to talk about Avogadro's principle and the ideal gas law with our remaining 40 minutes. Say what? Yeah. Oh, well, you're going to need a notebook for the rest of the semester. But you are not going, how many sheets you know? You are not going to make it for the semester. You are going to struggle with you, much less the semester. What are we talking about? Number 5? What's the answer? I did it before. We'll take 8, multiply by 760. So 8 times 760, about 700. So 6,008. Is that what you got? And that's fine. Yeah. Now, odds are good. Those of you who got some weird number, got ATM's right. You have 0.746 for the Torah conversion, and you got some jacked up number for CA. As long as your work is all there, on good, then you will lose points for your PA number and -5, provided all your work is documented. Yeah. Please don't let us hang. Okay. Did you do yours at KPI? Brandon's right. I was right. And the KPA number is wrong. It's only 5 points. Everything else is fine. Agilent is going to lose 5 points for EA conversion. Same for Andy. He's got enough documentation for 5 points. Passion is correct. Isabel, you have 1 point, another 1, 3, 2, 5 times 10. I can't tell if you wrote 5 or 3. Okay, you got 4.4 when you converted, and you should have gotten 4.4, 4.5. You got 7.9 when you added versus 8.0. I give you full credit. I don't have any issues with 7.9. The work is all documented. John, you are going to lose 5 points for your PA. You left off the exponent on top of the fifth, amount of 5. And she and yours is correct. You did good at school.
I don't know why my own teacher was converted.
After today, you won't. All right. So, Avogadro's present. Did y'all write it down? Wow. I left it up there while we were talking for you to write it.
So we were listening to you.
Any other time nobody listens to me?
I didn't.
Why did that? Why Adam was going to get? Yep. All right. Is that right? All right. How about now? All right. So, Avogadro, first of all, is the same guy that we talked about way back in, what, about third week of the semester? That's exactly the guy. Because 6.022 times 10 to the 23rd equals 1 mole. Now, he said essentially that if we know that this volume of gas has one, make it a little bigger. All right, it's really small. All right, that if we know that this container has 1 liter of gas, any kind of gas, oxygen, helium, nitrogen, whatever gas you got, and we know this other container of gas also has 1 liter of gas. Right? They both have 1 liter. Now, assuming they're sitting in this room, Can we agree that if they're sitting in this room, that they have the same temperature and pressure in this room? Sure. Well, we know the temperature in the room's not changing, right? Some of y'all would say, dang, it's cold in here, Ms. Wall. Need some heat. It's always cold in here, y'all say when you come to the room. Some of y'all go, came from gym third period. It's a little warm in here. Ain't you cool it down in here, Ms. Wall? All right, depends on which class you're coming from. But most people tell you that my room's a little cool. It's not as cold as Miss Thornhill's room if you had her for biology class, because her room's like an ice box. Okay? Now, some people are like Andy, and he's all feel good in there. Most people do not agree with you, however. Okay? So the temperature and pressure in this room, though, is pretty constant. It doesn't change, right? But if I have 1 liter of gas in this box and 1 liter of gas in this box, what does Avogadro say about the box of gas? That's right. They have equal numbers of molecules. Now, do we necessarily know how many molecules that is? No. We don't necessarily know what that number of molecules is. We just know the number of molecules is what? Equal. But Mr. Avogadro is very bright. He went a little further than just saying, if the volumes are the same, then the molecules are the same. Okay? Catch up with me. We're drawing over pictures. Okay? So, let's say he goes back. And instead of saying he's starting with a volume, let's say he takes 2 containers, and instead of putting a volume in the container, you know, we learned about moles from Mr. Avogadro, right? So this time, he puts 1 mole inside of the container. Okay? Now, if he puts 1 mole inside of the container, how many particles did y'all learn were in a mole? Say the name, like, got some confidence over there. Okay. It says that like, I'm not sure I have the right answer. I know she does, but she doesn't think she has the right answer, but she does have the right answer. And we're going to label these as a molecule since that's the word we use to Avogadro's process. Okay? So, instead of starting with volume, this time he put the molecules in the box. And he said we have this number of molecules. We have 1 mole in each container. And since we're talking about the gas laws, what temperature and pressure do you think he decided to use? And there you go. So he said, let's use some STP here. Now, according to what we just talked about, if molecules equal, then we know volume equal, right? So, what did you tell me about the molecules here? They're equal, so the volumes have to be equal, right? So, Avogadro said, I'm going to figure out the volume, which he did. He said the volume of 1 mole of any gas at STP equals 22.4 liters. It has a name called standard molar volume. And the best news in the scenario up there on the board is you don't have to memorize it, so it's where on that reference table you have. So, if you have 1 mole of a gas its volume will be molar volume. So if you have 1 mole of gas, what will its volume always be? 22.4 if you're at what temperature and pressure. Yeah. Okay, so this comes with a whole lot of stipulation. You have to have 1 mole. You have to have STP. That's a whole lot of stuff to keep track of. I don't like to use that particular number, so I don't make people memorize. But that's what it is anyway. I'm going to teach you a different way to come up with that number. Does everybody have what they need? Now, how are we going to use Avogadro's principle? Here's a sample problem. So I'll let you write your sample problem down. Add up another problem. Oh, these are pretty good. What? What's the matter? I guess. All right, do we have it written? You didn't even take it with you? Chasing you down and she doesn't even have to. She doesn't have anything better to do but wait on you to look at it. All right, we're there now? All right. Tell me what's different about this question than the one you did on the food. It gives you molecules, that's one thing. All right, what else is different about it besides it gives us molecules? Okay. What'd you say, Andy? Okay, well, it has a number of molecules, so that's the same thing. What else? Okay, this time we have 2 constant values. All right, in the questions you worked on the quiz, how many things did you have that stayed the same? What? You had temperature that didn't change, you had pressure that didn't change, but you didn't have 2 things that stayed constant. Okay? This time, you can't use any of the formulas that we use because this time, temperature and pressure are both constant. Can you imagine trying to plug in like V1, P1 equals V2, P2 if pressure's constant and you got to take out the pressure? Well, what do you got left to plug in? Nothing. All right, or if you had V1, P1 equals V2, P2, and then you use the combined gas volume, you said, okay, well, what is the temperature? And you're like, oh, temperature and pressure are both constant. Oh, dang, back to the same thing I had. You got a problem, right? So, what do you notice next then about your volume? What do you notice about the volume? What? Okay, they're the same. Okay? You notice the volumes are the same. Okay? That's the next thing you need to notice. Volumes are the same. So when you see that the volumes are the same, the thing that should start to pop into your head is Avogadro's principle. Okay? When you read volumes are the same, temperature and pressure is not changing, Avogadro's principle should start to pop into your brain. Now, what should Avogadro's principle mean? If volumes are the same, what do you know about the number of molecules? They're the same, right? So that should mean to you, oh, if they're the same, number of molecules equal 5.23 times 10 to the 25th. So, did I have to do any work? Did I have to do any work? The molecules were where? All I had to do was what? Read and write it down. I didn't have to calculate anything, did I? Most people get this question wrong on the test. They start drawing charts. They start dragging in equations. They do all kinds of bizarre things on the test. MOLC is the abbreviation for molecule. MOLC is the abbreviation for molecule. Okay? Not mole. Like ATM. It's not an atom, it's an atmosphere. MOLC is the abbreviation for a molecule. We don't call them mole.
Why not? We don't take it.
No, it is not. It's like boy less. They're not. It is not. They're not metallics. They're not. They're just not. Okay? Y'all are going to leave here, and if you listen to her, you're going to sound like idiots. Okay? Or you're going to have the world's worst chemistry teacher. So, if we go back to what I was talking about. So the volumes are the same. Okay? So if the volumes are the same, the molecules have to be the same. There's no work involved. Now, let's say I try to be super tricky on the test. Not that I would do that. But let's just say I did. The trickiest I would be to change the volume to 10. What did I do to the volume? Okay, I doubled it. That's times it by 2. So what would you do to the molecules then? Not divide it by 2. Times it by 2. So all you would have to do is take this number and multiply it by 2. That's it. Okay? Everybody with me on that? Until I put it on the test and you still get it wrong. Say what? Because I doubled the volume, I would have to double the molecules. Yes. Okay? All right. Our new topic for the day is PV equals nRT. If I had to guess which gas laws you would see on the exam, and you made me choose, I would either guess the combined gas law or this one. And if you made me really narrow it down and say you will see one if you're going to get a gas law, this would be my pick. All right? No, I never get to see the test. I haven't seen the test in probably 7 years. I'm always given a math or an English test or a social studies test. I just pray it's not a EOG. Those suckers are 4 hours. Now, these things still stand for that. But the other 2 letters are new. And this formula is different from the others because this formula has designated units. So, N stands for moles. Why is N moles? Well, M is used for what variable? What do we use M for? Mass. So we're going to use it tomorrow. We'll learn 2 new formulas tomorrow where M is mass. So N is moles. R is the ideal gas constant. Now, the ideal gas constant has 3 numbers listed on your blue sheet. because I'm the all-knowing, powerful Miss Wall, I get to choose which number we're using. I could keep all three numbers. We could rotate between them. But I have found over the years when I do that, drives my students crazy, and my weaker students are like, what the world are you doing, Ms. Wall? I cannot follow that. So, I am choosing to use one ideal gas constant. And the one I am choosing to use is 0.0821 liters times atmosphere over mole times Kelvin. Now, this number is on your reference table. You don't have to memorize it. But I will tell you now, without any issue, that not a soul in here will need to look it up on a test day. You will use this number so many times, it will be committed to memory. Most of you will have it memorized when you return tomorrow to do your homework. Okay? Now, the unit is where the important part lies. That unit tells us how this number is different from the other two ideal gas constants on your reference table. Okay? This number tells us that every time we calculate pressure, our pressure has to be in what unit? So, when we calculate a word problem, if we don't change our pressure to atmospheres and use this formula, we get the wrong answer. Every time. Our volume has to be in what unit? If we don't change our volume to liters now, we get the wrong answer. Temperature has to be in what? Not a problem. We've been changing kelvins now for a while, so we got that one. And then N, we're learning today, is mole. Not a problem, because we're learning that one. The two that are going to bite some of us in the rear are pressure and volume, because, for example, Sheena has been using those TORs. Isabel and Eiley have been using KPA. I don't know why, but they like those. So, because they've been using those, they're going to be tempted.
I need to buy a cruise to find out.
Okay. So they're going to be tempted to keep using those. I have to remember to switch to ATM and liters. All right. So let's do a couple samples, and I think you'll think this is a pretty easy formula. So this one's an easy question. We'll do this one, and maybe two more. I would write at least one or two of them down. Now, all of these are different. None of these are the same question or exactly the same, so that you have some differences. Got up? Where is this question? Stay home. More on anyway. No. No, I'll feel like I talked something when I grade y'all. Grading those tests are just, I should stay home. Might as well. Yeah. All right, so if we look at this question, first of all, aside from the fact that I know it's TV schools that are stuff for eons, how are you going to know that? What if this question jumps out at you based on what we did on the quiz, what we've done the last couple of days? How does this question look different to you when they're mixed up on the test next week? Will it say to you, oh, what jumps out? First thing, okay? This is the first thing you should notice. Now, there's one other obvious thing that should jump out at you that I need you to notice. STP you had on the quiz, but it does relate to STP. Sample reaction. How many numbers do you have up there? There's only one STP. There's one temperature and one pressure. Everything on the quiz had how many? Okay, 2 temperatures, 2 pressures, 2 volumes. But in this question, you have exactly how many? 1. Okay? So, when you go fill this in, this is an easy one because there's nothing that's going to require us to convert. When you look at temperature, what's your temperature? Okay? It's in the right unit. What's your pressure? It's in the right unit. All right, R. This number right here. Every time you need R, that number. All right, moles. All right, and we're solving for volume. So, before you plug in chug, check your unit. Atmosphere is good, moles is good, kelvins is good. So, when we solve, that means R, all of those units. You can write them down, but it just clutters everything up. All right, so, what unit will volume turn out to be in? Will turn out to be in liters. Okay? So, this will be in liters when we solve. So, PV equals MRT. Pressure is 1. Volume we want. Moles is 0.0680. R is 0.0821. Temperature is 273. So, to solve, I'm going to divide by what? 1. So, 0.0680 times 0.0821 times 273, and we get 1.52, and then liters. Question about how to do that? Anybody? Feel okay with that one? All right, write that one down. Oh, I have a couple of these, but I have several 20s and 30s. This one's going to be in the 40s. So, I'm much better on the 47. That's fine. Fine. When you done? Dollars board, and I do need board. Oh yeah, but on hand on. You got it ready? All right, so when you look at this, again, what do you notice is different? What jumps out at you? Do we do anything with a gram? No. And again, how many volumes and temperatures do you notice? You notice one temperature and one volume. Those are the things that are going to kick in that you should notice about this question that jumps out at you. So, P, V equals M, R, and T. What do you know from the question? What? The V? What's the V? 150 ml. Okay, what else do we know? Temperature is? Okay, what else do I know? N is 15.2 grams. Okay, what else do I know? So we're looking for pressure, right? Okay. So check your units. Before you can plug and chug, are my units what they need to be? No, which is where our problem lies. So Kelvin has to be changed to, or Celsius has to be changed to Kelvin. So add your 273 and we get 298 K. Now, if this was a quiz or a test, you need to show me adding the 273. No, that would be a standard deduction. I'm not even giving you -2 for the calculator to do that wrong. All right, grams to moles. Grams, moles, moles get to what? What's the mass of nitrogen? Why was I not writing that? Remember when I told you that y'all were going to be sexy because y'all were like, watch this, I'm going to do great on this next test, and y'all are going to get those tests back. Now, believe I made those mistakes. That's one of those that's going to be nipping at your heels, costing you 3 points on all those questions. Yes, because it's not atomic. The mass is not 14, the mass is 8. I'm just doodling on the wall over there, and he keeps yelling out 14 like I'm deaf. Yeah, and I kept doodling on the wall like it was not 14. Okay? And nobody was coming to your rescue, Andy. Did you notice that? Finally, Eiley stepped up to the plate, but everybody else just going, why didn't you answer him? Yeah. Okay? 0.542 moles. Okay? Now, is everything good to go now? Looks not good. All right, so we got to change it to, so we're dividing by 1,000 and liters. Now are we good? Oh yeah, so now we can plug in. PV equals nRT. Pressure I don't know, so I'm going to write P. Volume is 0.15. N is 0.542. R is 0.0821. Temperature is 298. So, get P by itself, I'm dividing by what? 0.15, 0.15. P equals something. So, 0.542 times 0.0821 times 298 by 0.15, I get 88.4. So, Eiley says the unit is ATM. Do we agree with her? You should. She has the right answer. Questions about how to do any of that? Do we feel okay about using the formula? I have 6 minutes. Hey, how about, does I have what I need? How about you do? Instead of me do, you. No, you only had to write it down. You got two samples, so you write it. You captain it. Oh, I got you the work. I don't know the answer off the top of my head. Now, I don't actually have the answers memorized to every sample problem I have and every problem I find. Did everybody get this far? All right, so what do we got to do from there? Got to go mole to what? Grams. 1 mole, and I've got chlorine. What's chlorine's mass? 71. So I get 3.04 roughly grams. Y'all get that? So you got island? Is that like yeah, or like yeah, small? When they're attacked, they're like stuff. All right. We're doing questions number 1 through 7, B only. Okay? So find the problem for this top. We're going 1 through 7, B only. Okay, I didn't have to yell at y'all last time about making sure you show me work like I did first period. So make sure you show me work. 1 through 7, B only. You know, I'm getting pretty good at this teacher.